Well, welcome everybody. It's another session today. I've got a super interesting guest today, partly from a sort of personal point of view. Daniel Lenton, who is CEO at Ivy, did almost exactly the same field of study in his PhD that I did in my master's 27 years ago.
Crazy.
Daniel, welcome.
Well, thank you so much for the kind introduction. Yeah, really great to be here. And I didn't know that, actually. I didn't know. So were you doing robotics and things like this?
Okay, let's start with that. So I studied artificial intelligence and software engineering between 1993 and 1997.
Oh, wow.
And then I did an MSc in cognitive science, which was the first year that the University of Birmingham put on that course. It was like, that's kind of how new it was. And it was just like, you know, the sort of like pretty new field of let's get people together from the computer science faculty and the philosophy faculty and the linguistics and blah, 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 blah. And sort of like munch them all together and try and figure out, you know, if that helps move things. And at the time, didn't do anything because it was like the deepest, darkest AI winter.
Of course.
Yeah. And so my master's thesis had a neural network. I remember this. It had 60 perceptrons in the neural network. So
was it single layer as well? Was it just like
it was a three-layer network, but it had like, I think it was like and I had to write, you know, I had to write that entire thing by hand in C++. And the most I could wring out of I think it was a 486 at the time. And you know, we had a Sonos workstation, and you had to go and set the thing training with a nice level, I remember, and then come back in the morning and hope you hadn't pissed too many people off by consuming resources. So
that's really when neural nets were uncool, definitely.
Yeah, they were deeply uncool. So that I've been talking too much. So do you want to just give us a background of what you've been, what your academic background is and what you've been working on most recently?
Yeah, sure. So I definitely, first of all, got into neural networks before they were that uncool. So I don't quite have that same claim. I got in relatively early. A quick background. So basically, initially did mechanical engineering at Imperial College. I realized quite quickly that, I mean, I do like engineering. The reason I went into that is because I probably could have done some very good marketing in my high school where there was like wind turbines and green future and all these things that I was really quite passionate about. And went into that, but realized I wasn't as into aerodynamics and planes and gearboxes and stuff quite as much as I was the coding side of things. We did like a super high level course on MATLAB, and I was like, I really like this a lot more. So then started like watching Python YouTube videos and C++ YouTube videos, even though there weren't really courses for those. Did like kind of hobbyist robotics projects and stuff in my summers. There was like 3-month summers. Wasn't easy to change over to computer science degree because in the UK you can only have another year of student loan, and by that time it wasn't really easy for me to change. But I stuck with engineering, but kind of did everything I could with all my powers to choose the most robotics, computer science related stuff that I could. That there was a little bit of room for, and I was quite fortunate that my master supervisor pretty much let me self-supervise my project because it was really in an area that they weren't like super expert in, but it enabled me to like dive deep into computer vision. Anyway, so the masters finished, and then I was thankfully on the back of all of that able to leapfrog into a computer science PhD in robotics, also at Imperial College, this time in the Dyson Robotics Lab with Andrew Davison. And this is then where I was really in my element. Starting that, I was like quite good at coding, and I used a bit of we used quite a lot of C++ in kind of these kind of Xbox Connect and point cloud cameras and things like this. So used a bit of C++, used a bit of Python, but nothing really like proper complex software engineering, because it was always like one project hacked together for a few months to get something working. And then really met some amazing software engineers in the lab, kind of learned a ton from them. And basically, so it's quite a long story, but basically, we were using Caffe at the beginning. So I joined in 2016. So that was, you know, when AI was really on the rise, but still, it was still pre-transformer paper and stuff. So we were using C++ and Caffe to start with. Then we were using TensorFlow when that came out in 2016. Then probably half of us moved over to PyTorch in 2017. I interned at Amazon on their drone program in 2018, where we were using MXNet. Others then turned at DeepMind, where they started to use JAX around that kind of time, 2019. We had people joining from Japan, where they were using Chainer, another framework. So basically what happened was there was this huge kind of explosion of frameworks. It was really hard for then researchers in our lab to collaborate together and to, because everyone was doing the same kind of fundamental 3D vision, robotics, etc. So a lot of shared like themes and knowledge, but not shared code bases because of the fragmentation. And I found this really annoying. It was a nightmare for new PhD students, and I wanted to do something about it. So I ended up diving, deep into this project called Ivy, which initially enabled the creation of framework agnostic libraries. So it wasn't about converting code or anything like this. It was about writing a library for mechanics or for computer vision or for robotics, writing that library once in a way that was kind of abstracted such that it could work with any of these frameworks that we were all using. And then we could have these shared code bases and shared models, etc. That worked well. But as time went on, basically felt as though the fragmentation in the entire field was, the fragmentation in the lab was kind of reflected in the entire field. Nobody seemed to be taking the problem too seriously. There was things like Onyx, which are great, but still have a lot of downsides in my opinion. So I ended up just diving even deeper down this engineering rabbit hole, all at the expense of research that I also am really passionate about. So in another life, I kind of keep doing that as well, but I ended up just becoming so obsessed with this infrastructure problem, and certainly kind of, yes, still kind of not look back and no regrets, because I think it's quite a fundamental problem that could benefit a lot of people, and that's super exciting to me. And then the company was formed about like 15 months ago, maybe now, beginning of 2022. At that time, it was a handful of stars, and GitHub and myself as a sole contributor, so not too much to look at. And then in the last kind of 15 months or so, we've gone from a few hundred stars to getting on 11,000 stars, and got over 11,000 in our Discord now, nearly 1,000 contributors. So like people meaningfully contributing towards this. We're still basically pre-release, like on the actual final release, which is coming out in June, so a few weeks from now. And I'm pretty confident about that, so I'm kind of not too scared to say that. It will be coming out sometime June. Anyway, so that's kind of slightly bigger answer than the question you asked, but that's kind of my personal background, origin story of Ivy, kind of rolled into one a little bit.
So going back to my my experience when I stopped working with neural networks, which was then, right, like it was powering a it was a virtual robot. So back then, there weren't any, you were literally writing the code for, a perceptron and actually, learning object-oriented programming, which actually lends itself quite well to a neural network. But are you, for those, because it's very hard for people not directly working within the field of AI and machine learning to sort of follow. You mentioned the transformer paper. I know that is important and seminal, but I don't quite understand what that means in terms of like the history of. So first of all, let's can we just go back and say, right, break it. If we decompose, decompose things, like there's a model that comes out the end that you can save and send to someone and they can load. There's the engine, which is actually running the runtime of the network, and then there is a language that you write to design the network. Or can we, how do these pieces fit together?
Sure. So I mean, so to try to get this just entirely verbally, without kind of a diagram or something, it is it depends on how granular we go. But I guess on those 3 points, yes. So my way of thinking about the model would be quite abstract. It's like purely mathematics. So the model is this mathematical function that's completely devoid of any hardware or engine. It's like purely numbers and additions and matrix multiplications. And this is therefore why you can kind of imagine taking ChatGPT and re-implementing it in a new framework, because actually ChatGPT is under the hood just kind of a big complex mathematical function or something like this. Which obviously transcends the medium in which it's being executed on.
So I mean, like conceptually, we can just think about it as a very, very, very big equation.
Exactly. Yeah, a super complex equation with exactly, basically. So just like a mathematical equation. And then the engine, I guess, again, these things all get a bit overlapped, but there's then this like which is also obviously more general than just machine learning. There's like this big just software hierarchy in general, right? A lot of it which is not machine learning related, which is kind of hardware and CPUs, then assembly language, then compilers, and then kind of LLVM and this compiler infrastructure that tries to unify different hardware vendors and so on. And at some point, what you typically, at least today, then get up to is like a C++ layer. So yeah, so all of the machine learning frameworks today are compiled using the C++ pretty much. Then what you have now on top of this like pre-compiled, pre-written C++ kernels, which in the case of a GPU includes pre-written CUDA-C code to kind of parallelize these kernels on hardware, on NVIDIA GPUs. Then what you have are these like high-level packaged functions like matmul. For those who are slightly into programming, then anyone familiar with NumPy, this is the kind of level that we're talking about when we talk about these frameworks. So matrix multiplication, addition of entire arrays, subtraction of entire arrays, doing these kind of element-wise functions at this kind of API level, and composing those together is the machine learning frameworks. And that is what PyTorch is. PyTorch, TensorFlow, JAX, NumPy arguably as well, and several others are then this fragmented set of frameworks. And then Ivy is actually not only trying to unify the frameworks, but also things below the frameworks, which includes the compiler infrastructure, and it also includes the hardware, because we see an increasing Cambrian explosion of hardware vendors coming onto the scene, as well as compiler infrastructure, which are, many of which are very much specifically focused on AI because of how much of a big market it is. So there's a lot of hardware vendors popping up that are not just making super general computers like CPUs, but they're making like things that are really, really good at executing neural networks in different, memory regions and performance regions. And we want to have all of those interconnected so that you can always have access to the best combination for the job, whatever that might mean for you. If that helped a bit. Another thing I would say quickly, just because you were mentioning about kind of programming individual neurons and things like this, I have no idea what the status was like back in kind of the 90s exactly, but now at least most networks are done with fully connected. I mean, at least when matmul happens, it's kind of representing a fully connected layer, and therefore all of the kind of layer 1 to layer 2 fully dense interconnection is all just represented as a single matrix multiplication. So there's no kind of, at least for the user, there's no like individual programming of neurons and their connections.
Right. Okay.
So that's all just matmul basically as well. Because sometimes when people see this big interconnected network, you might think that you're kind of, having each weight kind of explicitly this separate, object or something, but it's just a big matmul. Yeah.
So there's several layers of abstraction going on here. Is that yes. that keep getting built on top of those things?
Exactly. Yeah. Exactly. And also, just for anyone that's listening along, we have a page on this actually, who's listening on this asynchronously, which is basically our related work section. So I mean, maybe we share the link in the description, but it's like unify.ai/docs/ivy/overview/related.work. .html. But if you go into our docs and just type related work, then there's a big image where we show this stack on quite a granular level. But certainly, as you're saying, it's certainly quite a even that image, which has like eight or nine levels in the hierarchy, is a simplification to some extent. Yeah.
Wow. Okay. Right. And so, in terms of like the actual hardware that are running these, that are doing the learning for these models and then running them once they've been trained.
Yeah.
Has that hardware been successfully abstracted away for several years now? Is it kind of like you almost don't care whether you're running on the video card in my computer or some special designed ASIC in Google Cloud somewhere?
Yeah, well, to some extent it has. Each framework obviously wants to make things as simple as possible, but they also don't necessarily have aligned incentives to connecting to everything always really well. So like, let's say TPUs, which are Google's tensor processing units. Of course, TensorFlow and JAX, which are both languages and frameworks, sorry, I should say, which are used extensively in Google, have much better support for TPUs.
Right.
PyTorch, which has its origins, now it's a foundation, but it has its origins much more with Meta. I mean, yeah, there is something called Torch XLA that supports this, but there's just not the same incentives for the people, you know, the main people who are like really advocating for supporting PyTorch. A lot of deep learning teams at Meta and so on, they're not like, you know, super kind of bothered about making sure that Torch supports TPUs really, really well, for example. So there's lots of kind of sparsely connected layers. So there's like all these 9 layers, let's say, or you could, you know, you could simplify these and group them, but there's all these layers and there's just sparse interconnections when you go down. So every framework has the ability to go down to hardware without you caring about it, obviously, but they just don't have access to all of them. And our thinking is, well, actually, if you did have access to all of them, when you're like working with a sparse subset, there's a high chance that you have a suboptimal solution for whatever you care about, because there's a lot of great things by other people that you just, you know, don't have those connections to. So we're basically taking an unconventional approach. And I also wanted to just say, because, you know, it could be easy for me to paint a picture where everything's fragmented, everyone just wants to lock in, we're the only people trying to unify anything. And that's not the case. There have been standards emerge at various levels. Some a bit lower down, there's something called the Open Neural Network Exchange, which is trying to create a standardized representation on top of hardware vendors. There's OpenXLA, released from Google recently, which again is like, you know, technically vendor agnostic, but it's most relevant for TPUs now, and so on. But I think what we're doing differently is, rather than saying, hey, here's the standard, now everybody can plug into this, we're saying, no, we're never going to get consensus. Let's proactively bind to everything, so we don't need consensus. We don't expect or need anybody else to do work for us. We're just going to make sure that every conceivable endpoint is connected as part of our interconnected web, and we're going to do it in such a way that it is scalable, it's not too much work for us, and then our efforts, you know, are basically arguably aligned with everyone else's, because we're just bringing them along for the ride and making it work more easily with everything else. And I think there's no other tool that's doing that in quite the same way that we are at the moment. There's others that I should mention as well. So I'm probably adding more complexity than is helpful, but yeah.
This is a kind of, it's kind of strange, because it feels like I'm peeking through into a different dimension of, you know, because I you know, my experience is I understand all these layers in, you know, a SaaS cloud computing world.
Yeah.
But it's kind of amazing how quickly that kind of like just, you know, just feel like you're peering into a different world, and yeah, all these type, you know, these concepts and abstractions are you know, they're kind of mind-boggling. But I guess, so can you explain, like, prior to Ivy, like what would be a typical like wall that you guys would hit, you know, in your labs?
Sure. I mean, so in our labs, I have to be honest and say it was a slightly different time. So in our labs, we were like, the origin of Ivy was directly addressing a deep fragmentation problem of the frameworks at the research level, which that particular part of fragmentation has to some extent subsided, because we had people using TensorFlow, JAX, PyTorch, you know, Chainer. Some people still using Cafe because they could have more control over the memory management. But now the research scene, at least in Western universities, has converged more towards PyTorch. So some of the kind of things that Ivy is particularly, and there's a lot of things Ivy can be used for, but just to kind of rein things in, one of the things that I think Ivy will be very useful for is taking existing PyTorch code and just making it run faster, because there's a lot of demonstrations. If you take a look at the Hugging Face recent posts and recent efforts, a common theme is that by re-implementing very popular PyTorch models in JAX, they can get almost or over a 70 times speed up, which is huge, obviously. For like enterprises deploying these things, that's massive. Yeah. And basically, the difference is use JAX instead of PyTorch, run it on a TPU instead of on a GPU, and do a few like tricks that only JAX offers, and you get this huge speed up. So like, this is just another example that, you can have this really sophisticated tool chain under PyTorch, which is the main framework, and a lot of clever people working on it. But there's a much bigger world under the stack that doesn't connect to all these things. And if we can unlock that, then that's a lot of value to create. So that would kind of probably be quite high on the list. But more broadly, another thing that a lot of our early users are interested in is just the flexibility of prototyping. So what Ivy uniquely enables is for anybody with one line of code to take any model or library or function from any other version of any other framework, and in a single line, they can bring it directly into their project. So 2 examples would be, let's say that your entire project, and you have your own like trainer classes and data loader classes for kind of experimenting, and now DeepMind, and this isn't PyTorch, you have your own like PyTorch setup. And then DeepMind release a new state-of-the-art model that gets a Nature paper, and it's amazing, and everyone's jaw drops, and it's all in JAX because DeepMind publish everything in JAX. And you can't then quickly try this thing out in your pipeline. You can painstakingly re-implement it, but the devil is very much in the detail in machine learning. So, maybe subtle deviations are hard to detect, and you don't have the full confidence unless you spend a decent amount of time doing it. And then you're kind of bottlenecked by your own implementation time efforts. Whereas actually in reality, there's a ton of amazing things coming out all the time. And if you could get these things converted over in a few seconds, you could try, so many more ideas so much more quickly, and get good at better products to market more quickly. So another big point is this speed of thought experimentation that is really unlocked with Ivy. And I could list more, but because I think what we're doing is it's quite a fundamental piece of tech. It's not super verticalized at all. So there's a lot of different ways people are interested in using this, but these are some of the top ones, I would say. Yeah.
And so, how do you go about, like, let's say I've got something running in stack A, and then I read or hear you say, oh, I can get a 70x improvement if I use Ivy to port it to stack B. How do I know that the outputs coming out of stack B, they're not guaranteed to be exactly the same as the ones coming out of A, right?
They're not exactly the same to the point of the exact ones and zeros, because basically our abstraction level and our intermediate representation is at the level of the mathematical functional API at quite a high level. So if like mathematically, I don't know, kind of tan or sine or cos or whatever, like actually low level, there can be approximations made that differ slightly.
Right.
But what we've seen is we have extensive unit testing to basically verify that within a very small rounding error that we get the same results. And what we've also shown, and actually this was something we showed in our ODSC West talk in November last year, and also will be one of the demos that's released in a few weeks. This is the case for a very large model. So what we've shown is you can take a DeepMind model for perceive IO, a very deep transformer model. You can transpile this to TensorFlow, JAX, PyTorch, etc. And then when you pass the same image in the input, you get exactly the same predictions. It knows that it's a dog, with 80% confidence and so on. So even with these these rounding errors, because it's true, we never get exactly the same floating point representation for any output really. Right. But these don't propagate to kind of create noise at the end, and it's very, very stable, which is a good thing. And also the user can just test this. So if they have their PyTorch model and now they do this one line of code to convert it to JAX, which is now 70 times faster, they just put the same input in, do a quick unit test and make themselves confident it's the same. And we can verify that as well, basically.
So it's more about just being at a certain confidence interval that they're behaving,
Exactly. And one thing I would say as well is that, another thing with Ivy is that it's very good for converting for training as well. So if you then want to refine tune the model, or you want to take the architecture and retrain it, then this is completely irrelevant anyway, because the mathematics is correct, and you're going to then maybe kind of hone in on you're then going to improve these slight reductions. But from our experimenting, the loss in accuracy from doing this transpilation is something in the order of a fraction of a percent, maybe 0.2% or something. So for many cases, 70 times speed up and a 0.2% drop, particularly when this can be overcome with some fine tuning, is a kind of worthwhile trade-off, basically.
That's super interesting. So, and just coming like, yeah, I mean, I was just looking at your star history. Like, you guys have done a cracking job. Like, you've really come out of the gate, and
Seems like it.
yeah, like absolutely smashed it. So, what was the story in terms of like the first line of code, and then when it started to get put up onto GitHub? Was that just you literally by yourself trying to solve this problem that you had locally?
Sure. So yeah, the truth is, so basically, yeah, when the company was first formed, and I mean at the beginning, there wasn't really the resources to kind of, I could never build Ivy to what it needs to be on my own. So I had kind of the idea out there, and I had version 0 basically. But when I first put it out there in 2021, I was still finishing my PhD, and it was really kind of a part-time thing. I then started to properly take it more seriously in January 2022. That's also when we got our first kind of small investment. So what I did then pretty much was we indexed kind of most computer science departments in the world. We just got emails sent around for internships. We put job ads on every job board we can find. We weren't too worried about like only trying to get people from top universities or kind of really exclusive undercover. We were like, no, let's just get as many people knowing about this as possible, because my hypothesis is and continues to be that like computer science talent is relatively uniformly distributed across the globe, much more so than it is with like fields which have much more insider knowledge. So like lawyers, you can't get the inside knowledge unless you go to certain, law schools or something,
right?
Which is a bad thing. It's very bad for like social mobility and so on. Whereas actually, in comparison, software engineering is thankfully relatively democratized, because the internet access is increasing all over the globe all the time. There's amazing like free resources to learn all of this and everything. So anyway, so basically, we just kind of wanted to get as many people saved as possible, and we have this fully remote setup, so it doesn't really concern us, someone's location too much. So we're really trying to get the best people, regardless of where they went, what their CV looks like, etc. And we pretty much disregard the CV. Anyway, all of this to say that this was maybe a bit of a catalyst, because then a lot of students started saying about this. They started to apply. That got the flywheel rolling a bit, and now just word of mouth spreading just continues to push things forward, because we don't do that as much anymore actually. But I think that just like was a bit of a catalyst, and people said, oh, this seems really cool, told their friends about it, and now we seem to have a large community of, yeah, like I think 11,500 on Discord, where everyone is very excited for the release to come out. And so I think another thing just to put a cherry on top would be, I think it helps as well that our project is like unreasonably parallel.
Right. Yeah.
Like,
so this is a common thing that actually we haven't really talked about explicitly on the podcast before, but there are some open source projects, especially ones that have like a plugin concept, and like 80% of the code base is plugins and stuff. I always think like Home Assistant is the perfect one, right? They've got like this like thousands and thousands of contributors and stuff, and then you've got others like Flagsmith, where it's very serial, and it's very difficult. So and I get, you can't really choose that, right? Like it's just like you turn the card over and it's like, oh, what I turned out the projects I've got is really
face, arguably as well. That's also kind of quite just a ton of models, like everyone can just contribute something. So I think we just benefit from that, and I think that obviously helps, because then like every applicant that applies needs to make a pull request, and that pull request needs to get accepted in order, like it's the first phase of the assessment. The pull requests aren't compared, like it's just an entry level, and then the actual kind of assessments start, because every pull request is different. It's not like it's meaningful work, so you can't really do apples to oranges comparisons anyway. Some people luckily have a pull request that's pretty quick, some are a bit longer, but it's still a baseline that gives some entry level. Anyway, but that means that basically, we have 1,000 contributors, and they've, as part of the application, and also just telling their friends, and it's this thing where to like add a new pull request to Ivy can take as little as 30 minutes, because adding one function to one framework in the front end or back end actually can be done quite quickly. So it's this thing that people can plug into and out to as well, which helps as well to kind of increase people's sense of involvement, but also actual involvement. I mean, it helps everybody feel part of the community, but they also are part of that community, because we couldn't definitely not have done this without such a large team of people working on it. So it's kind of the perfect project in that sense, I would say.
And have you found commercial organizations have been contributing to it, or is it more kind of like, I don't know, hobbyists or people who just have a specific problem that they want solving?
So at the moment, for now, it's predominantly hobbyists and researchers and students, but that's mainly because we are still basically, I mean, this will change when it comes to a few weeks from now, but the version that's available publicly is a version that requires people to write quite a lot of Ivy code. And this is something that isn't that commercially relevant right now. So what I would suspect that will change once Ivy is actually properly usable. But these whole abilities to convert code between frameworks and the ability to deploy very efficiently and take a PyTorch model and run it on JAX, these are not publicly accessible yet, but that will change in June at some point. And I think then when people are more seriously using it, then of course there is this property where it's very easy for people to fix their own bugs. So let's say you really want to run this PyTorch model in your organization, which can be an enterprise, and you want to run it, 70 times faster, and you want to do that like right now with one line of code, then but there's one function that's missing in the PyTorch front end, or one function missing in the JAX backend. Like when you try to do ivy.transpile, it's just going to say this almost worked. There's these two things missing. Here's our pull request. Once you do that, you set like maybe bleeding edge mode equals true, so that you're not like bound to the pip version, and you can actually just pull straight in. Then it will work. So then you're just bottlenecked by yourself getting those PLs accepted. And I think this is where we can start to increase kind of commercial engagement and contributions, because it's basically fix your own bugs. But at the moment, it's more the community is more people for whom the story resonates, and they want to be part of the solution, because we don't have meaningful usage yet. People's own engagement is, this is awesome, I want to like be part of this, like movement or something, and they're therefore just contributing towards that first major release, basically.
So just looking at your GitHub, 1,700 issues and nearly 200 pull requests. So how are you sort of managing? How are you managing or not managing? Like I always think of I mention this from time to time. The HashiCorp Terraform folk, they just gave up. They admitted, like, right, we're not gonna accept any new issues or pull requests. We just need to, because we just we've kind of lost. I mean, it doesn't feel like those numbers are quite there yet, but how are you? And in terms of like the tooling, I'm always kind of curious to know at kind of that scale, do you feel like there are tools that are missing from GitHub that would be helpful?
Yeah, so I can give you a bit of an overview of our process. So first of all, we have about 30 engineers on the team at the moment, and all of those have a recurring responsibility to review pull requests, basically. And that's how it was at the beginning. So at the beginning, obviously, I reviewed them all because it was only me.
Right.
And then, on day one, the first intern we hired, they were responsible for reviewing them, and with me, like 50-50. And then at some point I stopped doing it myself, just got swamped with other things. But now everyone on the team who's an engineer, he does that. So that means it paralyzes without anybody spending all day like reviewing pull requests.
Right.
It's like kind of something people like to do, and we very much frame it as like engaging with the community. It's not always the most efficient way to get the work done. And quite often it may not be, but it's something that's really long-term valuable, because we're kind of onboarding people and explaining it, and even if they do or don't get an internship, they then are familiar with the process, and there's someone else in our community who's meaningfully contributed, and we want the experience to be as good as possible for them. So people enjoy doing this as well. In terms of the other processes, I mean, we've done a load of bespoke stuff. So we have a GitHub Enterprise plan. We have a lot of people on the team using GitHub code spaces, for example, because it became a nightmare. I mean, I personally use PyCharm with Docker integration just so we can have the same consistent environment, but that needs an enterprise plan, and some people find that annoying. And anyway, so we ended up just going with code spaces. We use every single minute from our CI is crazy. We have so many tests, and we use Hypothesis for property-based testing, and we have a whole team dedicated to making the CI. We have a MongoDB account to kind of store the test results, and a dynamic dashboard built in React to view it and everything. So we spend a lot of time like putting a lot of effort on our tools. There's a few things that which are a little bit more kind of AI based. There's one thing that we're working on, again, not super secretive. We're just exploring using AI for actually automatically creating the pull requests, because our tasks are incredibly modular and quite self-contained. We're training our own LLMs, so a bit like Codex or Star Coder, but a bit different, trying to make the front-end implementation, run our tests. It's very easy for us to make the tests because they're just self-consistency based. Using Hypothesis, we don't write test cases, so we can write all the tests with ease. So the AI has access to the ground truth test, has access to the failures of the test and the stat trace, and it can then iterate on its own previous implementation. And if it really gets stuck, then at least hopefully we have a good starting point, like a good template for an engineer to come and pick up the pieces without having to write the whole thing from scratch. This is something that will really accelerate the workflow if we get it right. But another thing that we did find a bit annoying, I'm just kind of thinking out loud here, obviously, we found that we wanted to use the issues, but never found the interface that nice. Sorry, not the issues. We wanted to use the discussions, right? But never found the issue that nice, and it also then ended up being fragmented because we also wanted to use Discord, and we use Discord for all of our internal chats actually on private channels rather than Slack or something, just to have us all closer community. And then, of course, if the question or the discussion is open source, and okay, if it's a public topic about public code, then we always encourage the team to have that conversation on a public channel, not a private channel, and so on, just to kind of close the loop with the community. And then having another one, having then the discussions on GitHub, and then maybe having Google Chat was just too much. And the interface wasn't great. Yeah, but there's nothing that screams at us as being something that's really missing in the workflow yet, but there's always things that can be improved, of course. Yeah, this is how I see it.
And do you feel there's a huge amount of potential value creation happening in a very short period of time, right? Potentially, especially with OpenAI and folk like that. Are whereas in the kind of SaaS world, people are very, companies very sort of, open and sharing in terms of open source tooling and stuff. Is there still a little bit of a kind of, if there's a commercial entity initially, are people still a little bit kind of over guarded in terms of I feel like that's some sort of, I don't know, valuable IP, and I don't want to share that, or is what I've just said misfounded, and actually people are super, super sharing?
So I think I kind of followed all of that. I mean, so in AI, I think it really varies, because Hugging Face are super sharing, although I say that there's a slightly different license on some of their new stuff, but broadly speaking, it's all open source models, and it's their kind of engine for running things that they then make money on. But their value creation has been, through the kind of community and mindshare more than the revenue, I would guess. And others obviously increasingly so. I mean, one thing I say is that there is a trend. I think as AI moves away from the kind of research lab spin out and hobbyists, which it was only a few years ago, everything was open source because that was kind of how you got attention, because everyone's researchers in the field. If it's not open source and they can't play with it, then people aren't going to care about it. Right. But as there's kind of this more, and also because researchers held a lot of power, because the reason that I think Google and Meta and all these companies and OpenAI said yes, publish top tier research, is because all of the thought leaders in AI are predominantly first and foremost researchers at pursuing research careers, and what people are motivated by there is much less money. It's partly altruism and interest and curiosity, but it's also the prestige of their name, and that they're then etching their name into the kind of permanent record of research history. And if you go and work, certainly when I was thinking about jobs and everything a few years ago, if you go work to a company that says, yeah, you can keep publishing papers and you can have a high salary, and another company that says, no, you're building an in-house product, and there's no public record of what you've done, you just have to rely on what the kind of reference from your supervisor or something, then that's less attractive. But I guess as things become properly commercial, maybe the things swing a bit, because partly because of the prestige of working at these top companies, the money is like another level and everything. But I still personally think that a lot of, and also another point is that maybe you don't need the top researchers to be in the top enterprises to make a ton of money. Like, even if all the researchers and the really kind of creative thought leading people want to stay in somewhere where it's open and open source and everything like this, and therefore AI remains fundamentally open source at the cutting edge, that wouldn't stop like the previous research of a few years before, which is kind of what ChatGPT to some extent is. It's like oldish research with like, you know, mass scaling.
Right.
And with some tricks, of course. It's not as simple as that, but it might not even be necessary to have thought leading researchers in those institutions for them to do like mass stuff, and then for them to become big companies. All of that to say is it's very like, it's a turbulent transitional time, it seems. A lot of companies, AI companies, are not open source at all. Many of them still are. There's alternatives to things like ChatGPT, which are becoming open source, which are doing very, very well. Of course, Google, it was just a random employee, I think, but saying that they have no moat, and I could see that there is very little moat apart from perhaps the branding and the user experience and the initial mind share. But in a way, like, if someone can make another version of ChatGPT but make it cheaper or something, then I don't know. I think open source is going to be an important part of the story. So I was a bit meandering.
You know, it's interesting actually. Like, I mean, do you think? You know, I remember going from an iPhone 3 to an iPhone 4, and it was like, you know, bloody hell, like, this is like amazingly much, you know. It feels like we're kind of very much there in the AI models, right? Like the difference between 3.5 and 4 for ChatGPT was like huge different. Do you think there's a you know, if that slows down, then things might calm down a little bit, do you think? Or
again, to be honest, probably, like, I mean, you would take my opinion with a pinch of salt, because I've been so deep in the infrastructure these last few months that I've not like really been able to unpack what's happening with the research frontiers of LLMs and stuff. But yeah, I know that GPT-4, but I feel as though, basically, I don't know. Really, like, it could be the case that we're running out of data and everything, and therefore we hit a ceiling and we need new algorithmic innovations.
Right.
Fundamentally so. I think maybe the reason that GPT-4 was a bit underwhelming compared to ChatGPT is because the thing that was exciting about ChatGPT wasn't the technology. That the technology was kind of well known in the research community. It was just the like super simple interface. Like, we've been using GPT-3 for a couple of years for various things, like helping to respond to questions and things like this. And we would only ever use anything like this with an API key, an API call. But ChatGPT suddenly, like, probably multiplied by 1,000 the number of people that can engage with this. And this was like this huge, like, watershed moment. And GPT-4 is a lot better in lots of ways, I think. But it's not like quite a fundamental shift in like human, you know, accessibility to AI in the way that ChatGPT was. So I think there's still a lot of progress going on, and computers, like, in the hardware level, NVIDIA GPUs and everything, and the amount of investment that now will flood into, I feel as though like the computing resource and power will get cheaper and more efficient, because now there's this like moment, like, AI is the new is the new Bitcoin or the new crypto or whatever. So there's going to be a lot of amazing capabilities unlocked because of that, and I would still expect there to be exponential growth. But I also don't think that AGI is like 5 years away. But I feel as though, I mean, depending on how you define AGI, but I think there's going to be like something that's totally indistinguishable from a person when communicating with them, you know, within the next few decades for sure. So I don't think we've hit a ceiling, really, personally. But, you know, I could be wrong.
And do you worry that there's like potentially too much money still going into the field? Or
I think what there needs to be most likely is just like maybe regulation on products. I think like the research shouldn't stop. There was an interesting talk with Jan LeCun and Andrew Ng that I watched a couple of days ago. They kind of said the same thing. Yeah, I feel like stopping the research is not good. And also, like, how would that work in practice? Like, I mean, like, I don't know, like Russia, China, these countries are only going to be a few years behind us in the grand scheme of things. Like, if we stop it, other people won't, and like what's that going to achieve? Like it will continue, and therefore I think what we need to do is try to think very carefully about not like stopping the research and stopping the scientific discovery, but just what's the kind of policies and stuff around the product and things like this, because I think like misinformation is a big potential application of it. But again, like I also don't think it's necessarily quite as existential as it might seem, because there's already like a huge like suppression and indoctrination machine in many of these countries anyway. There's already like meddling with elections and stuff, and I think that's probably where my existential risk comes from, because like if the ability to detect when you're being manipulated gets harder and harder, because there's like this kind of huge paralyzation of efforts, where like if, let's say, a country wants to meddle in another country's election, they can just like synthesize, you know, millions of people online super convincingly. They can like flood likes and what top comments top, and if the internet as a whole cannot distinguish who's real and who's not, then I think there's big issues. And my personal thinking with it, again, pretty uninformed view, and I haven't thought too much about it, to be honest, but my gut feeling is that one of the big safeguards will be to have like really good authentication, where like the "I'm not a robot" button you click on Google and all these things just get way more strict, so that you can't have robots or AI agents going out doing like crazy stuff en masse on the internet.
Right.
I think that is existentially worrying, personally.
Yeah.
Just for like, you know, human beliefs, because we're like so malleable, right? Yeah. Like, society. So like, if an AI wants to like, you know, control elections, then, you know, we can already do that without super intelligent pretty easily with like, you know, newspapers and stuff. So I think AI could easily do that.
I do think the human captures are getting more and more surreal as well. Like, that's kind of fun.
I imagine like, maybe what you need is like an iris scanner. Maybe like every time you log on, it needs to open up your camera. There needs to be like this super secure way that guarantees it's a real camera. Like scanning your iris, touch sensor. I just think like that level will need to go up, and we'll need to make sure that there aren't millions of robots like, you know, manipulating human consciousness and human opinion and things like this. But
so I've just got, I know we're short on time, but I've just got a couple of questions, and one of them is a personal thing, and it's a bit cheeky, but can you explain transformer algorithm to me in like 2 minutes, and why, or the paper, and what was so seminal about it?
I can, but I haven't like kind of gone through it in such a way, like in a while. Basically, it enables you to learn keys and values to then like look at yourself. So it's kind of like, here's the information I have. Now I want to like attend to parts of this information well, and I want to learn how to do that. And then when you kind of do a dictionary lookup, you kind of have this like mapping of like keys and values, and then you kind of take the ones that are most interesting, and then you just use those or something like this. Whereas basically what attention does is it kind of makes like a soft differentiable version of the, like, if you imagine then like you have a dictionary and you like add the key and you then take that value, and that's a hard discrete process where you just take one number, or you take 5 numbers out of a dictionary with 500.
Right.
Or you can do like a soft approximation that's like a differentiable version of that, where like you read from all of them a bit, but you read from some based, you know, more strongly than others. And it kind of just like made a soft version of attending to all of your information, learning the keys and the values, and then like creating a new matrix which is based on these. That's my high level version of it. I would probably, I've not read the paper in 2 years, so I could get something much better probably if I read it again. But this is like the high level gist, like learning to attend to your own information and learning those weights of like.
And this is kind of like structural within the network model. Is that
exactly, yeah,
right?
Exactly. So it's handled with kind of the map Merlin. Then there's a like a dot product or something. So it's all just like within the network itself. The actual architecture of the network has these in it. So no matter what you do, the architecture, the like mathematical control flow has these processes, and you are necessarily learning the weights of these processes. This is how your reasoning must be done. It's like the substrate upon which the reasoning can be implemented, and all you can do as a learning algorithm is modify those weights. And it's like, well, okay, this is what we're doing. We're like, you know, attending to our own information. How best should we do that to solve the problem? And this is kind of then what the learning algorithm does, basically, like step at a time.
Well, okay. I mean, I vaguely understand what you're talking about here.
Yeah.
And so so finally, like, so what's next for Ivy, both like as a project and a business? Yeah.
So good question. So first of all, to be honest, like we're running before we can walk. We're only really thinking of really kind of the next few months ahead, and certainly the rest of this year. Basically, what we want to do is provide and verify that we are providing a lot of value. We're in a position where we're not like desperate to jump on a particular business model. We're also blessed to be backed by investors that also understand that this could be quite transformative. And first of all, we just want to verify we're building something that is of general usage across the field, get adoption, mind share, and these kind of things, and not worry too much about the other things first. Of course, we're thinking about that as well. And so basically, like we want to release this in June. Once it's out there, we're also working with a lot of amazing projects as part of our GSOC mentor. So we're GSOC mentor this year.
Right.
So we're working with Hugging Face and implementing some Ivy models in the Hugging Face repository, working with Cornea and PyTorch Geometric and GradSlam and kind of 10 others. Well, actually, only 3 of them were officially selected, but we're going to still partner with all those projects and many others. So the idea is we get a lot of blog posts written alongside these amazing projects, maybe get Jupyter notebooks on their READMEs, on their master branch, on our master branch, and so on. So I think if we can just show this like mass, and just as an example, like what one of those might look like is Cornea. Cornea is an amazing computer vision library for PyTorch. What we can then do is say, well, now there's a new function called Cornea as TensorFlow or Cornea as JAX, and now suddenly the entire vision library and all of its hundreds of functions are now usable in your version of your framework. And we can also give that project that high-level function which just thinly wraps ivy.transpile. And I think this could be quite powerful to really just like demonstrate that en masse with 10 lines of code per pull request, we can make every project out there instantly framework agnostic. And this is something we really want to see how far we can go with that and how useful that can be, and just see how people are using it. And we're also getting design partners. So we are working with some enterprises and just getting early feedback from them on their like enterprise teams, their engineering teams, how they're finding it useful and everything. So we're really just going to listen. Like we're going to get it out there, see what people are doing, ask people how they're finding it, learn what value we're creating, and just kind of be an absorbent sponge and iterate based on the things that are good and so on, and hopefully keep refining something that's broadly useful. So yeah.
Yeah, I mean, it's always tough, especially when you're growing, I guess, at the rate you are. Like it's super hard to not feel like constantly on the back foot and tiltering backwards off the back foot, right?
Yeah, absolutely. And particularly in a field like this, I mean, now the AI hype is real for the last few months. So the number of kind of companies with these broad sweeping, like hugely general, we're the this of this and of this and everything, and like all these much more verticalized things are coming up, like train your own LLMs, and it's kind of really like specific to a company. We're obviously doing a much more general infrastructure play and just trying to as well find the nugget. We're doing an infrastructure play that's like super broadly applicable. It can do lots of very different things and be used in different ways, and finding the right verticals to kind of market ourselves with is something that's an ongoing thing, because it can do lots of things. Maybe it turns out that 70% of the usage is converting PyTorch to JAX to make it quicker. But I still think that there's merit in terms of future-proofing yourself and adding a moat for us to do things the right way and to be truly unified and future-proofed, because PyTorch isn't necessarily the winner of the whole ML race. Because of things like modular and Mojo, but anyway, that's a whole other topic. But this is how I think about it. Yeah.
Well, Daniel, thanks so much. That was super interesting. I'm not disappointed in that last hour personally. And yeah, like congratulations on, and thank you so much for it's great to hear like your that attitude of like just stay with your ear to the ground, and I think that's super respect for you for doing that. So thanks again for your time.
Thank you. Likewise, really great to chat with you, and chat again at some point in the future.